Today, let's take a look at several common valves used in chemical production. So, let's get started. The four types of valves shown here are the most common shut-off valves in the chemical industry. Their main function is to connect and disconnect the flow of media within a pipeline. Although some of them can be used to regulate the flow rate, we cannot use them entirely as regulating valves. First, the ball valve. This is a very versatile valve. Developed from the plug valve, it opens and closes by rotating the central ball within the valve body. It features flexible operation, a small size, lightweight, low fluid resistance, and effective sealing. Ball valves are divided into floating and trunnion-mounted types. The main difference lies in the way the central ball is supported. A floating ball valve. The ball has no support shaft at the bottom. It is supported by the two valve seats. When operating under pressure, the ball will shift slightly toward the outlet seat. If the pressure is too high, it will accelerate the wear on the sealing surface. A trunnion-mounted ball valve. The ball is fixed by upper and lower stems, and the other end of the stem is connected to a bearing. When under pressure, the ball will not shift. The bearing takes the force, so the pressure on the sealing surface of the seat is not high. The internal structure of a trunnion-mounted valve is more complex, and its price is also relatively high. Floating ball valves are generally used for pipelines up to DN 200 in low to medium pressure applications. For high pressure, large diameter pipelines, a trunnion-mounted ball valve would be selected. Although ball valves can provide some flow regulation during use, it is generally not recommended to use standard ball valves for regulating flow. Keeping a ball valve in a partially open state for an extended period will greatly reduce its service life. The impact of the media will damage the edge of the ball's bore and the valve seat's sealing surface, causing internal leakage. Second, the gate valve. As one of the most common valves in the chemical industry, it is also one of the oldest, with a wide range of applications. The closing element of a gate valve is the gate itself. The gate moves perpendicular to the direction of the media flow. It achieves the shut-off of media in the pipeline by closing against the valve seat. The gate valve has a simple structure. The media does not change its direction of flow when passing through, resulting in low fluid resistance. It is easy to operate, has a wide application range, provides stable and reliable sealing, and is durable. However, it has a long travel, a long opening and closing time, must be either fully open or fully closed, has large external dimensions, and requires a certain amount of space. Gate valves are divided into wedge gate valves and slab gate valves. Their difference lies mainly in whether the two sealing surfaces of the gate and the valve body are in a parallel state or a wedge-shaped state at a certain angle. A slab gate valve. The force pressing the gate against the seat is provided by the media pressure and the expanding mechanism between the two gates. The sealing surfaces are always in contact during the opening and closing process. This can prevent particles and suspended matter in the media from affecting the sealing surface, achieving a self-cleaning effect. The media pressure will affect the force on the downstream sealing surface. It can seal well even under high pressure and high flow. A wedge gate valve. The sealing principle of a wedge gate valve relies on the combination of the wedge-shaped gate and the sealing surfaces on the valve body to achieve a seal. The sealing pressure comes from the media and the downward pressure on the gate. Because the gate of a wedge gate valve has a slope, the sealing surfaces can separate more quickly during the opening process, resulting in less wear. However, it is more prone to seizing after prolonged use. Adhering deposits and hard particulate impurities will damage the sealing surface. The cleanliness of the media directly affects the valve's service life. Gate valves have almost no regulating function. Like ball valves, they can only be used fully open or fully closed. In a partially open state, it will cause significant vibration and impact, damaging the valve seat seal and reducing its service life. The third type is the globe valve. The closing element of a globe valve is a plug-shaped disc, and the sealing surface is flat or conical. The disc moves up and down, changing the distance between the disc and the valve seat. Just like the stopper on our thermos, it blocks the media's flow path. The disc has a short travel, opens and closes quickly, is wear-resistant, has a long service life, and its single sealing surface is easy to maintain. However, the media's velocity and direction change inside, causing high fluid resistance. The opening and closing process works against the media pressure, making it difficult for large-diameter, high-pressure applications. Globe valves are directional. With flow from bottom to top, it's easier to open and reduces packing leakage, typically used for low to medium pressure pipelines. With flow from top to bottom, it's easier to close and improves the seal, making it suitable for high-pressure pipelines. Common types of globe valves include the straight-through type and the Y-pattern type. Their main difference is the flow path of the media inside the valve. The Y-pattern type causes a slightly smaller pressure loss. The straight-through type is the most common model. Its internal structure is similar to a Z-shape. In use, they can provide some flow regulation. Compared to ball valves and gate valves, there is less wear on the sealing surface during regulation, making it suitable for small diameter pipes. The Y-pattern type has less impact on the media's flow direction. It is generally used in situations where there are requirements for media pressure loss. The fourth type is the butterfly valve. It uses a central circular disc that rotates with the stem to open and close the fluid channel. Butterfly valves have a simple structure, are small, lightweight, can have a large diameter, and operate quickly and flexibly. A standard butterfly valve can achieve a good seal under low to medium pressure. Compared to the other three types of valves, its sealing stability and durability are slightly worse, but its regulating performance is better. There are many classifications for butterfly valves, but I generally divide them into concentric and eccentric types. One relies on the elasticity of the sealing surface material for a self-adjusting seal. The other can be assisted by an external force for an enhanced seal. This is somewhat similar to the relationship between slab gate valves and wedge gate valves. Within the eccentric type, there are single, double, and triple offset designs. These refer respectively to the axial offset between the sealing surface center and the discus rotation center, the radial offset between the valve's flow path center and the discus rotation center, and the angular offset of the sealing surface. These are all design improvements aimed at enhancing sealing and reducing wear. Finally, let's summarize. 1. Ball valves are widely applicable. Use floating types for low pressure and trunnion-mounted types for high pressure. Try not to use them for flow regulation, unless they are specialized regulating or V-port ball valves. 2. Gate valves are durable and widely applicable, but their operation time is relatively long. When operating, do not use a cheater bar, as damage to the sealing surface is irreversible. Also, like ball valves, do not use them for flow regulation. Globe valves have high fluid resistance, only recommended for no requirements on medium pressure loss, for small diameter. For butterfly valves are actually quite comprehensive valves. With the development of technology, the sealing of the valve, durable and applicable, have been greatly improved. It is flexible and adjustable. It is commonly used in low pressure. If you have any questions after watching this video, just feel free to contact ThinkTank for a free consultation.